All right, agents, listen up. Welcome to the briefing room. Think of this explainer as your tactical extraction mission for exam marks. Your target, the Cambridge IT 9626 exam paper. Your mission, should you choose to accept it, is to extract maximum marks from a highly hostile environment in 20 minutes or less. We are specifically targeting a zone of the syllabus where most candidates completely blow their cover. Section 19.1, Common Graphics Skills. Now, you might be thinking, hey, I know how to use graphics software. This is going to be a breeze. Well, that's exactly what the examiners are banking on. We're going to decode the secret language they're looking for when they interrogate you on adding and removing layers, altering layer order, toggling visibility, and locking or unlocking elements. Because out there in the exam hall, it's a war zone of lost points. Look at this intel directly from Cambridge headquarters. This quote is straight from the Senior Examiner Insights. They're telling us, plain as day, that this is a massive opportunity. Let me introduce you to two operatives who typically fail this mission. First, we have Alex. Now, Alex is smart, but Alex absolutely overloads their answers with raw computer science facts. They'll write a whole novel about what a layer is, but completely forget to analyze the actual scenario. 0 marks for context. Then we have Sam. Sam's got the opposite problem. Sam rushes in, guns blazing, completely ignores the command word requirements, writes, I logged the layer, and expects an A*. Obviously, both of their exam papers come back covered in red pen. It's literally painful to see students bleeding marks when they actually understand the software, just because their strategy is flawed. Today, we are using the Principal Examiner reports to flip this weakness into your ultimate exam day superpower. Okay, here is the mission agenda. 1. Core principles. 2. The procedural framework. 3. Critical analysis. And 4. Top examiner warnings. Let's move. Section 1. Core principles. Thinking like an examiner. Right, let's get into the theoretical foundation. The absolute golden rule here is that simply clicking buttons in your graphics software isn't going to cut it for A-level. The examiners aren't testing if you know where the hide button is. They're testing what they call the strategic application of these 4 fundamental tools: adding or removing layers, changing layer order, adjusting visibility, and locking or unlocking them. You have to think like the strategist grading your paper. What's the causal relationship? If you are an agent infiltrating a system and you lock a specific layer, what exactly does that cause? What disaster does it prevent? That level of precision is exactly what we need. And to get that precision, top students structure their answers using the PEEL framework. That's point, evidence, explanation, and link. You make your point about the tool, you provide evidence from a specific graphic in the exam, you explain the technical impact, and you link it back to the overall goal of the task. If Alex had used PEEL, they wouldn't just be stating facts in a void. If Sam had decoded the command words before rushing in, they'd know exactly how deep that explanation needed to go. Now take a look at this comparison on screen. This right here perfectly illustrates the battlefield. On the left, we have superficial breadth. This is our friend Alex, just dropping definitions. On the right, analytical depth. This is where the top marks are hidden. Superficial breadth is writing a bulleted list of everything a visibility toggle can technically do. Analytical depth is explaining exactly why hiding a specific, say, text adjustment layer in the provided poster scenario alters the entire message of the final composite image. Examiners want analytical depth every single time. And honestly, this is a great time for a quick interactive challenge. Imagine an exam answer says, the visibility tool hides things. Is that superficial or analytical? Yeah, it's painfully superficial. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Seriously, getting these strategies weekly is how you build that analytical muscle. You have to decode the command words. If the command word is evaluate and you just describe, you failed the mission. Okay, before we leave the core principles, I need to share a highly classified secret directly from the examiner reports. The candidates who truly max out their marks, they do something special. They explicitly integrate their graphics knowledge with other areas of the syllabus. They make cross-topic connections. The IT 9626 syllabus is a web. It's not a bunch of isolated islands. Think about it. If you can explain why locking a graphics layer isn't just about stopping accidental brushstrokes, but actually ensures data integrity for a broader team-based IT project, boom. Or how toggling layer visibility directly impacts user interface design and accessibility, you are practically forcing the examiner to give you top marks. You're showing them you see the whole matrix, not just a single pixel. Moving on to Section 2, the procedural framework, the method mark strategy. All right, so we've got the theory. Now, how do we execute this on paper to guarantee extraction of those marks? This is where we transform those red pen corrections into green check marks. Cambridge operates on what we call the method mark strategy. What this means is that marks are awarded for your systematic process, your clear working out, not just the final visual output or conclusion. Think of it like a heist. Nobody cares if you just show up with the vault contents. They want to see the blueprints, the laser grids you bypass, the whole systematic processing. If an exam question asks you to propose a change using layer tools, and you just write down the final result, you are leaving massive method marks on the table. This is exactly the trap Sam falls into. Sam rushes to the finish line and skips the working out. We need to build a computer science success blueprint, a framework you use without fail every single time. And here is that blueprint. 5 standardized steps to method mark supremacy. I'm going to give you 60 seconds in your mind to visualize applying this to a past paper. Step 1, identify key elements in the question prompt. What exactly is the command word asking for? Step 2, apply relevant principles. Which of our 4 tools, layers, order, visibility, lock, actually apply here? Step 3, execute the analysis. This is where you write down your working. Step 4, verify the results. Does your proposed layer change actually fix the problem in the scenario? And step 5, present your final answer in the proper format. If you follow this sequence, you are building an airtight, heavily fortified answer. You identify the target, you pick the right tool, you execute, you confirm, and you extract. Next up, Section 3, Critical Analysis, Elevating Your Answers. Okay, to access those top-grade boundaries, we have to level up our cognitive domains. Notice how the progression on this table fundamentally changes the depth of your answers. At the basic level, we have descriptive thinking. That's just extracting data, stating what a tool does. A layer is like a sheet of acetates. Okay, great, 1 mark. Moving up, we have analytical thinking. This is interpreting the relationships. Moving layer 3 above layer 2 obscures the background. Better. But at the very top, that's evaluative thinking. Evaluative thinking is where the A-stars live. This is where you evaluate alternatives, question the assumptions in the prompt, and justify your recommendations with hard evidence. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Seriously, if you want to be evaluative, you need these strategies. Let's do a quick data scan challenge. Imagine a complex data table showing rendering times based on layer visibility. You've got 60 seconds on the clock. What's the core trend? It's not just that fewer layers mean faster rendering. The evaluative answer notes that hiding complex vector layers saves exponentially more time than hiding simple bitmap layers. That's how you extract the core trend like a pro. Let's look closely at how evaluative thinking applies to comparative analysis. When a question asks you to compare different approaches, like, say, using layer visibility versus just deleting a layer entirely, here is a massive key and a place where so many students drop the ball. Effective comparison requires you to point out both similarities and differences. Let's play Find the Flaw. Here's a flawed paragraph. Hiding a layer is different from deleting it because deleting it removes the data permanently, while hiding it just removes it from the screen. Okay, what's losing marks there? I'll give you a second. The flaw is that it only lists the difference. The examiner commentary on this exact mistake is brutal. To get full marks, you must use comparative connectives and state the similarity first. Both methods result in the element not being visible in the final exported image. However, the difference is, see how much stronger that is? You have to support both sides with direct evidence from the scenario. Section 4, Top Examiner Warnings. Red lights flashing, sirens wailing, agents. We are entering the most critical part of this briefing. These are the exact locations where past operatives have completely compromised their missions and thrown their grades away. All the beautiful, structured, evaluative analysis in the world won't save you if you trigger one of these examiner alerts. We're talking about a time management matrix failure here. I'm going to put a metaphorical 30-second timer on the clock for speed writing. If you can't write a perfect Peel paragraph while avoiding these next 3 traps, you need to rethink your strategy. Pay close attention, because this data is pulled directly from the principal examiner reports. So, here are the top 3 mission-critical mistakes. Mistake number 1, forgetting proper format. Students will write a brilliant technical analysis, but format it as a messy bulleted list when the command word clearly asked for an essay-style evaluation. Mistake number 2, failing to check format and presentation. That's Sam rushing out the door without double-checking if their proposed layer order actually achieves the client's brief. But mistake number 3? Mistake number 3 is by far the most dangerous trap in the entire exam hall, providing generic answers that lack specific context. This is Alex's kryptonite, writing an answer that is technically true, but completely irrelevant to the picture on the exam paper.
Look at the screen. You must always link every single point you make back to the given exam scenario. The classic mistake is writing an answer that could apply to literally any image ever created. Let's say the exam gives you a scenario about an architectural firm designing a multi-layered building blueprint. If you just write, locking the layer prevents accidental edits, well, congratulations, you just defined what a lock tool does. But that's generic. That gets 0 marks for application. To get the mark, you must be context specific. You must say, locking the structural foundation layer prevents accidental edits while the architect is adjusting the plumbing visibility layer. Do you see the difference? The second answer uses the exact details of the scenario. Context is absolutely everything. This is how you push your mark potential progress bar all the way to 100%. To ensure you never blank out under the extreme pressure of the exam timer, I'm giving you the ultimate cheat sheet. It's a quick memory hack. Take the first letters of our 4 core tools right now. L-O-V-L. Layers, order, visibility, lock. Say it with me, L-O-V-L. You can use L-O-V-L or make up your own creative mnemonic. The second you open that exam paper and see a question targeting section 19.1, I want you to write those 4 letters at the very top of your page. It will instantly ground you. It's your complete answering system. Combine LOVL with command word decoding, your Peel framework application, and a solid time management matrix, and you have a system that practically guarantees top marks. So agents, I leave you with this final provocative thought. When you sit down with your next past paper, which path are you going to take? Are you going to be like Alex, listing basic tool functions with superficial breadth? Or are you going to show true evaluative analytical depth, question assumptions, make cross-topic connections, and lock your answers deeply into the context? Students who implement these computer science strategies see an average improvement of 2 grade boundaries, 2 whole grades, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, AC Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @aceexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below right now with your target grade for computer science and the biggest challenge you're facing. Our team responds to every single comment. Like and share this video with a study partner. AC Exams, your Cambridge success starts here. Mission accomplished. See you in the next one.